Hi, I am Mukesh Kumar. Today we will learn load balancer. In Azure, there are four load balancing techniques. One is load balancer, another is application gateway, traffic manager, and front door. We will focus on load balancer in this section. Load balancer distributes inbound flows that arrives at the load balancer's front end to backend pool instances. These flows are according to the configured load balancing rule and health probes. The backend rule instances can be Azure Virtual Machine or instances in the virtual machine scale set. In this picture, you can see this is the client machine making a request to the load balancer and load balancer distributing the loads among the three machines. All the three machines are not exposed to the public. They all have private IP addresses. So this is a useful scenario when your loads is high at certain time and you want to distribute it. So not one machine will be responsible to serve your client, but you can add many machines as you wish. Load balancer works on the 5-tuple hash. We'll talk about this later. There are two types of load balancer in Azure: public load balancer and private load balancer. A public load balancer can provide outbound connections for the virtual machines inside your virtual network. These connections are accomplished by translating their private IP addresses to the public IP addresses. Public load balancer are used to load balance internet traffic to your applications, like the public facing websites. An internal or the private load balancer is used where the private IPs are needed at the front end only. Internal load balancer are used to load balance traffic inside the virtual network. A load balancer frontend can be accessed from an on-premise network in the hybrid scenarios. So consider this case where an entire application, a user makes a request to the public IP and the load balancer distribute the traffic evenly to any of the backend pool virtual machines. So you can see virtual machine 1, 2, or 3. Then further, virtual machine 1, which are in the web tier, can make subsequent requests to the business tier and which can be further load balanced by an internal load balancer. This load balancer is not exposed to the public. It has a private IP address. Again, your business tier can make further call to the database tier, and that call can too be divided into multiple machines. So again, we have used internal load balancer. The load balancer comes in two SKUs, standard and basic. In production cases, we mostly prefer standard, and there's a reason for this. In a standard, backend pool can be any virtual machine, but in basic, virtual machine should be part of the availability set or the scale set. The next difference is the health probe. HTTPS standard SKUs support the HTTPS, while the basic HTTP, so you mean basic tier, is not secure by default. The basic tier does not support availability zone, but the standard does. And the diagnostic, it has a rich metrics, but the basic tier metrics in Azure Log Analytics only for the public IP load balancer, and secure by default, as we said, yes. Some of the key points to remember about the Azure Load Balancer. The load balancer can be only used within a region, which means that load balancer cannot be distributed. For example, a virtual machine cannot reside in another region and load balancer in one region. So load balancer has to be in the same region. Azure Load Balancer operates at layer 4 of the OSI model, which means that does not control over the path or the any HTTP related or the application layer related settings. It supports IPv6 addresses as well. Load balance services on the multiple ports, IP addresses on both. The load balancer uses the health probe to control the health of the machine, so that if any of the machine goes down, then it will remove the machine from the load balancing rule, and it will not direct the traffic to that machine. And it can increase the availability of the distributing resources across the zone because it can behave in the same region, but it cannot work on the direct the traffic to the other region. But yes, it supports availability zone, which we discussed that like a standard SKU can be used to direct the traffic in different availability zone. So let's go for the demo part. To demonstrate the load balancer, what I have done is I have created three virtual machines within the same region. They all part of the same virtual network and the same subnet, VM1, 2, 3. I have remote control all of the three virtual machines and logged into the virtual machines. You can see VM1, 2, 3. In all the machine, I have installed web server so that we can test individual virtual machines. And in the web server, there is a IS root folder where I've changed the virtual machine name so that we can output the virtual machine host name. So let's go for the demo. Take the public IP address and you can see VM1. Similarly, if I take the public IP address of next two machines, then I'll get VM2 and VM3. Our goal is to create a Azure load balancer. And by accessing the IP address of the load balancer, I should be able to navigate to any of the VM1, VM2, VM3 based on the availability and based on the load balancing rules. Then let's create the load balancer. Give the resource group name. Region, type, public or private, which is the internal. I select the public. And there are two SKUs. We discussed about it. Basic and standard. For demo, I will take basic. And public IP address because this is going to be publicly available. So we need to assign an IP address. I'm using the existing IP address. Next is tag. I'm leaving it at default. Validation and create. So load balancer is created now. So there are a couple of settings we need to do in order to work the load balancer. So first thing first is ensure that it has got the front-end IP address configuration, which is a public IP address mapping, which we already done it at the time of creation. Next is we have to define the backend pool of the load balancer. So click on add. Give the virtual network name and associate it with the virtual machine. So you can define either the virtual machines, individual virtual machine, which should be part of the same availability set, or you can define virtual machine skill set and you can select the instances based on your requirement. So I have an individual virtual machine. They are same using the same availability set. So I can add them, add. Okay, okay. So our virtual machine backend pool has been added now. Next, we will add health probe. The health probe is required so that load balancer can pull our health of the virtual machines, and any of the health of the virtual machine is not good, then it will remove the machine from the pool. So here we define the port number. So port number is 80. So by default, we want our virtual machine to list respond on the port number 80 this will represent that the machine is on or not. But you can define your custom port. If any of the service, let's say that listening on certain port on the virtual machine, which respond as a health service, then you can define that as well. Interval, which is in the 5 seconds. So you can see if it is by default 5 seconds, which means that, and the unhealthy threshold is 2, which means that on the interval of 5 seconds, it will check the health of the virtual machine, which is it will poll on the port 80. And if it finds 2 consecutive failure, then that machine will be marked as a unhealthy. So click on OK. While it is updating, let's go on creating the load balancing rule. Click on the load balancing rule, give the name, again the port 80. So here we define the we can define multiple rules based on our requirement. So for example, if I want the our IP address listing on certain port, and that port has to be redirected to, let's say, port Y, then we can define this rule. For example, this is a source port, and then this is a backend port. So here we are not, we are leaving this port 80 as default, and we are redirecting it as port 80 because we are listening on the load IIS default site. Then what's a backend pool of for this port? This is the backend pool which we have created, the health probe which we have created, and sticky session. If you want to enable, then it is session persistent. You can see client IP or the client IP and the protocol. But we don't want this for demo purpose. And the idle timeout, for which it has to respond. So for example, 4 minutes is a maximum timeout. Click on OK. Okay, our rule has been added. So far, let's recap what we've done. We have created a load balancer. We have associated that load balancer with the public IP address. We have created the backend pool, created the health probe, and then we have defined a rule which defines that on which port what load balancer should navigate or redirect to the backend pool. So go to the overview, grab the public IP address, let me grab this public IP address and go to Mozilla. The reason I went to Mozilla because maybe the sticky session is enabled or my IP address is load balancer is taking my IP address, so it is always giving me the same, uh, directing me to the same machine. But I just tried the different virtual machines, so which different browsers, so that it can direct my request to the different virtual machine. So here I take the IP address and refresh this. It is showing VM1, 3. You can see. So I'm now hitting the public IP address of the load balancer on port 80, and it is directing my traffics to the port 80 on the backend pool, any available server. So you can see it is redirecting sometime to 3 and 2. Now 1 and 3. So now at the moment it is redirecting me to 3. Let me do one thing. Stop the virtual machine and see if the traffic goes to the other server. Now you can see the traffic is going to VM2 now. Again, VM1 and 2. So this proves that by accessing the same IP address of the load balancer, it is redirecting me to the backend pool of the virtual machines. I hope you have learned something new. If yes, then please like this video and do subscribe my channel for motivation. Thank you.